Sorry, here. Okay. Yes, it is possible to run Python directly on the login node. We know that, also including thin link nodes. But yes, otherwise we should use the compute nodes, as we have said. What was shown the last session was how to use batch jobs, and that means that you define the job and then you send it, but there is no way for you to interact with it directly. So it doesn't work very well if you are developing code, if you want to test if things works, and yeah, to find the bugs. And also if you want to look at the data and interactively like plot or make graphs of your data. So doing the analysis in real time. So then you need some more interactivity. And that you could do also on the compute nodes, but instead of using sbatch command, you use you start an interactive session with either salloc or interactive command. So that is basically this. So developing, you can also use Jupyter Notebook or Lab on the compute nodes. And it works in the same way as with batch. You use a Slurm system. You use the same options as for the batch jobs, like -p and -n, such things. But yes, it differs a little bit in how this works on UPPMAX and HPC2N. At UPPMAX, you actually are physically on the compute nodes. So when you come to the compute node after doing this interactive command, when you do the work interactively in the command line, you are actually on that node. We will see an example. If you're in a hurry, you can ask for the dev core partition, -p dev core. Then you can run shorter than 1 hour. So you book shorter time. But then the waiting times are much shorter as well. So within 1 minute, maybe you can get access, basically. It's a little bit different on HPC2N, but you can work interactively anyways, but in a different form, you could say. Yes, you know about this. Jupyter and other graphics would benefit from thin link. Also, there are possibilities to work closer to your own computer. And if you want to use Jupyter in an interactive session, you can click this link and there will be some instructions, both how to run Jupyter on on UPPMAX clusters and on HPC2N clusters. So let's try this out, or I will show it as a demo, I think. This is just how it works, but I will show you the example. If you want to, you can type along, but it's not necessary. So what I will do now is to make this a little bit smaller and activate my screen here. I will only show for UPPMAX because of the lagging time here. So I will ask for 10 minutes here, partition dev core, so it should start quite fast. Oh, yes, and I will also in the end module. Okay, I will skip this one. I just do this. So in this case, while it starts up, remember that I loaded module Python 395 before. So let's see if we find it also here, or if we have to define it again. Yeah. So yes, now it starts. And please see here, 25.6 gigabytes of RAM you can use. And that was because I booked 4 cores. And that is 4 times 6.4. So it's 6.4 gigabytes per core. So that's good to know. Even if you are not using several cores, like in parallel, for some analysis, maybe you need a lot of raw memory instead. Then you can book large amount of cores, because then that will give you more memory to work with. So that's good. Yes, okay. I was doing hands up, I don't know why. Okay.
Yeah, you raised the hands.
Yeah, there was some short command that I don't understand which one it was. So let's do what we have. Think module load and module list. I only have UPPMAX. So when we are on this new node, I have to load module, the Python module again. Python 395. So now it's loaded. Yes. We can now also run hostname. If I just run it once time by hostname, we see that we are on R483. That is the compute node number 483. You can also see it here. And you may remember that before it was written Rackham 1 or Rackham 5 or something like that. So on the R, that means that we are on compute nodes. If it was Rackham complete, then we are on begin node. I can also try to run srun host name. And then it runs 4 times. So that means that all the cores are used. So that's a way to really see that, okay, we really booked 4 cores this time, if you forgot what you did before. So this is run 4 times. So yes, I will not use these codes maybe, or will I? Can do that. I will go to programs. This. CD. Okay. ls. So I can try to do this Python add 2.py. Okay, 5 and 6. So it is only run one time. If I do srun, I will use all the cores. So I will do the same. Yes, and 4 and 6. Then you see it will run 4 times. So, okay, this is not the best code to show this, but if you are running some parallel code, then using srun will make it, make it available. So you can run it in parallel, basically. If you don't use this srun, it will not use the parallel functions. Okay, let's step out by exit, and screen is terminating, and we close this session on this node, R483, and we are back on the login node, Rackham2. Yes. And once again, we have some links here to running Jupyter on the compute nodes. We will maybe check this when we speak about the Dusk later today using Jupyter. So then we will have some hands-on on this. I didn't say, but on HPC2N, you use salloc instead, and it will look like this. So also here you have to load your modules. Yes.
Just mention the important thing there is you will not be on the compute node. You will stay on the login node, but you will have access to running on the compute node. So you have to use srun in front of any command to get it to run there. Otherwise, it will run on the login node.
Yes. Oh, yeah. So that's good. Yeah. So if you allocate this compute node, but still don't use srun, then you will use login node resources still, with some problems maybe for other users if you work with lots of data maybe. Yes. So by that, yeah, we could say something here. Yes, same procedure, loading Python module and possibly prerequisites. And also I could say that CPU hours are more effectively used in batch jobs because then you predefine what you're doing and you only use the time spent for the program to run. When you book interactive, you maybe book 4 hours, but maybe you work with the code, typing, and then run for a couple of minutes, and then work with your code again. So it's more expensive, I would say. So you will still be, yeah, you still use CPU hours for 4 hours, but you maybe just run your code for 10% of the time. So that's good to know that, yeah, how you distribute your work. But yeah, you use interactive for testing and developing or running fast things when you don't need so much time, but you want to get started immediately. And I don't know, do you have a development partition at the Kebnekaise?
No, we do not, unfortunately.
No,
we don't.
No, but in a queue system, typically, if you define, yeah, if you allocate short jobs and narrow, that means only one or a couple of cores, then the waiting time should be rather low, short, basically. Yes. So we take lunch break. We meet again at 1 o'clock sharp, and we dig deeper into the parallel and the HPC opportunities. So now we have learned about the architecture more, how to book cores and such, but now we look into the coding itself, basically. Okay, so see you in 55 minutes.